Okay guys, on this section for differentiation, we are going to look at derivatives of inverse functions, primarily inverse trig functions. But first we're going to get through just some regular inverse functions. Again, I'm going to be talking really fast through this whole thing to try to get through it in some record time here. So you're going to want to do a lot of pausing and rewinding. First, I want you to get the theorem down. So here is the theorem. And I'm going to point some things out to you. The continuity and differentiability. If f is continuous, then f inverse is also continuous. If f is differentiable on an interval containing c, it might not be differentiable everywhere, then f inverse is also differentiable at c. Now here is your main theorem here, and I'm going to kind of rewrite this in inverse function notation as well. Make sure you see that f and g are inverse functions. If f has an inverse function g, then we are going to be able to find the inverse function's derivative using this formula. And if I use f inverse notation, obviously the denominator cannot equal 0. If I use the inverse function notation, which is what you see quite often, then what you would see is f inverse, hopefully I can write this neat, f inverse prime of x is 1 over f prime of f inverse of x. So why do we need this formula? You need this formula because even though it seems like you can always find an inverse of a function, sometimes you just can't. We'll see some examples dealing with that now. Okay, so you remember the property of inverse functions where one of them is a reflection about this line, y equals x, right? So the line y equals x is like a mirror. If this is your function, then this is its inverse. For every point AB on the function, there's a corresponding point BA on its inverse, and that's very, very important for what we're about to do. Now, again, you won't always explicitly be able to find this inverse, so that means that you're going to have to find, have another way to get at least the derivative of the inverse at a certain point. So what we're going to do is use the formula that hopefully you wrote down. If you didn't write it down, go back, rewind, try again. And the formula is for us to be able to find the derivative of the inverse at 3 when we cannot explicitly solve for the function here. In other words, I can't get the inverse function. I can't let f of x equal y and then get the x by itself. Because since I have this 1/4 x cubed plus x minus 1, I actually cannot isolate the x term. So finding the inverse function is not even possible here. So if I can't find the inverse, then I can't find the inverse's derivative. So what I'm going to do instead is use the formula that we just went over. Now first we'll do the first step, which is finding what the value of f inverse of 3 is. So A is really asking, what is f inverse of 3? Well, the way I find the f inverse of 3 is you want to think, okay, if f, let's say f inverse. If f inverse has the point, and I just have a colon here, if f inverse has the point 3 something, then that must imply that f had the point something 3. Because if there's a point AB on a function, then the point BA is on its inverse. So all I need to do is set this f equal to 3, right, because that would be my y value here. So I'm going to set this equal to 3. And I guess I can swing the 1 over and see how much easier it makes it. So again, I have this function equals 3. So now 1/4 x cubed plus x equals 4, because I added 1 to both sides. Alright, honestly, at this point, guess and check works about the best. You can get a calculator out and have a calculator help you solve this. But if I just start to guess numbers, alright, what if I guess a 1? If I guess a 1, then when I cube a 1, 1/4 times 1 cubed is 1/4. 1/4 plus 1 isn't 4. Now let's try a 2. 1/4 times 2 cubed plus 2, does that equal 4? Well, 1/4 times 8 is 2, and 2 plus 2 is 4, so yes. That's telling me that 2 is the x value that makes the y value for the function 3. So if f has the point 23, then f inverse has the point 32, which means the f inverse of 3 is 2. Sometimes that's a little hard for people to wrap their brains around the first time, and I did say it really fast, so feel free to rewind, go back through it again. Okay, now it's going to be easier for me to answer B. What's the value of f inverse prime of x, the derivative of the inverse? Well, there was a formula. Go back and look at it again if you didn't get it. But the derivative of the inverse of 3 is 1 over f prime of f inverse of 3. Well, that's what we just found in part A, right? F inverse of 3 is 2. So now we know we want 1 over f prime of 2. Okay, well, f prime of x, and I'm running out of room here, but it's okay. F prime of x, just use your derivative rules. I'm going to bring this 3 out, so I'm going to get 3/4 x to the 1 less power plus 1. So 1 over f prime of 2 is 1 over 3/4 times 2 squared plus 1. So it's 1/4. Again, pause and rewind if you need to. And this is just illustrating it right here. These are the functions. This is your function. Which one's which? This is f. This is f prime. One slope is 4. One slope is 1/4. They're just reciprocal slopes. Okay, derivatives of inverse trig functions. So far there was one formula for you to write down on your cheat sheet. Now here are 6 more formulas to write down on your cheat sheet. I'm going to turn to the next page now, but first what you should do is pause this and write down all 6 of these formulas. You could write down the derivative of arc sine x equals 1 over the square root of 1 minus x squared. This is reminding you that the chain rule could apply if this isn't just an x, but perhaps maybe it's a function of x. Okay, so now we're going to use it. So the derivative of the arc sine of 2x, this is my u. So look at your formulas. Please, please, please be looking at your formulas, unless you've already memorized them, and then it's going to be really easy. You should also try to pause this if you think, and try them yourself before you listen to me or watch me give you the answer. Okay, so the derivative of the arc sine of u is u prime over 1 minus u squared. There's absolutely no way you can simplify this. The square root of 1 minus 4x squared, by the way, please do not tell me that the square root of that is the square root of 1 minus the square root of 4x squared, because it's not. So don't even think this. So that's your final answer. There's no way to simplify that. Okay, next, the derivative of the arctangent of 3x. Again, this is the arctangent of u. So look at your formula and try to do this yourself first. The derivative is u prime over 1 plus u squared. Okay, for the derivative of arc sine of u, I need u prime. So this is actually an x to the 1/2. So the derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then that's all over the square root of 1 minus u squared. Now let's simplify that. Because I don't have a quantity on the top, I can just actually bring this down to the bottom. So I'm going to make it as simple as I can. And that's what I'm going to do. For that matter, this is also going to be in the denominator. Or if you don't want to confuse things too much, you can take the top, the whole top, which would be 1 over 2 times the square root of x, times the reciprocal of the bottom. Okay, but either way, this is going to reduce to 1. There's nothing left on top but the 1. On the bottom we have this 2 and the square root of x and then times this. And the square root of x squared is just that. And it doesn't look that nice to have 2 square roots, so I guess I will simplify it one more time and distribute the x through in that square root. Okay, next one, look at your formula for arcsecant. Now, we're going to do u prime, but be really careful because u prime here is the derivative of e to the 2x. When you're considering e to the 2x, you want to think of that as an e to the u, because the derivative of an e to the u is a u prime e to the u. So, the derivative of e to the x goes on top, which is e to, I don't know what I said, but I meant e to the u. E to the 2x times the derivative of 2x. And then in the denominator, we're going to have the absolute value of u times the square root of u squared minus 1. So the only simplifying that we really can do is, first off, e's are always positive, but this whole thing's going to be gone anyway. This e to the 2x and this e to the 2x are gone. So, and then in here we're going to take a power to a power and multiply those powers. So this simplifies to 2 over the square root of e to the 4x minus 1. And again, that can't be simplified. A review of basic differentiation rules. We've learned a lot of different things. Polynomial functions are your simple power rule things. Rational functions would require a quotient rule, usually, unless you can simplify first. Functions involving radicals, that would be chain rules. Log functions you have formulas for. Exponential functions you have formulas for. Now not only trig functions, but also inverse trig functions. So please do pause, write all of these formulas on your cheat sheet, and the same with these.